Okay, welcome to your challenge round. Okay, we've been given a whole bunch of information here, and now the question is asking us to prove that this is a cyclic quad. Now there are three ways to prove a cyclic quad, and let's go through them quickly. So I've got converse op angles of cyclic quad. If I prove that the opposite angles add up to 180, then I've got a cyclic quad. If I prove that the angles inside of a bow tie are equal, then I've got a cyclic quad because of converse angles in the same segment. And if I prove that the exterior angle is equal to the opposite interior angle, then I can conclude I've got a cyclic quad because of converse exterior angle of cyclic quad. Now I believe it's going to be this one, and let me show you why. It's because we kind of already know what one of the exterior angles of the cyclic quad is. It's y. But it doesn't always unfold that way, so we've got to kind of see where it takes us. So let's keep that in the back of our mind. It is a loose guideline on what to do. So let's get started, mark off our information and see what we can do. Yes, nice, bro. Okay, so we're going to mark off y with blue angles. We're going to mark off x's with like this yellow angle. And we've got a tangent over here. Alright, and I'm seeing something. X is in between a tangent and a chord, my butt. We've seen this theorem like 6 billion times in this paper already. It's the tan chord theorem. Okay, so we look at the other line that X is touching. It's touching the line DE, which will be our chord. And then we follow that chord down and down again. And it takes us to an angle that's equal to X. So now we know that C equals X due to the tan chord theorem. And now if I have a look, I can see X and Y are inside of a triangle. Triangle DEC. And if I just extend the line EC, then we can see we've got an exterior angle of this triangle formed by E2 plus E3. Now E2 plus E3 will be equal to the opposite interior angles added together for the following reason. Exterior angle of a triangle. To get the exterior angle, you go to the opposite interior angles and add them together. So this whole angle here will be X plus Y. So it stands to reason that E3 must be the same size as Y. And it's a little bit tricky to write that up, so I'm going to walk through that quickly. So let's have a look at what we're going to say first. We're firstly going to say D1 plus C equals E2 plus E3 exterior angle of triangle. And once we've got that written down, we know that D1 is Y and we know that C is X. We proved that in the previous question. So we're just going to swap these to an X and a Y like so. And then we're going to state that E2 is the same size as X. They told that to us in the question. And now we're going to jump to the conclusion that E3 has to equal Y. And just for this line over here, you can put given as your reason. And then another nice way to imagine it. So imagine I change this to an X. So X plus E3 equals X plus Y. So it stands to reason that E3 has to equal Y. And now I'm going to direct my focus towards this Y over here. I can see it's touching this line, which is equal to this line, so it's inside of an isosceles triangle. And in an isosceles triangle, we always know that the base angles are equal, my bro. And that's for the following theorem. Angles op equal sides. If I look at the equal sides and I go to the angles that are opposite them, the angles will be equal. So now we know that B1 plus B2 will equal Y. And we're going to write it up just like this. Angle B1 plus B2 is equal to E3. And both of those are equal to Y. And we knew that because of angles op equal sides. And now our job is almost done. Look what we've accomplished. We've proved that the exterior angle of the cyclic, or exterior angle of this quadrilateral, is equal to the opposite interior angle. So now it is a cyclic quad. We've proved it. But there's a couple of things we need to state. We're not home safe just yet. So firstly, I've got to make the link between this angle and this angle. So I'm going to hit a therefore D1 equals B1 plus B2, just like this. And I knew that those two angles are equal because I went and proved that they are both equal to y. They both have a value of whatever y is, in a sense. And now we can copy paste this. ABED is a cyclic quad. And after we state that, we went down this avenue to prove it. That the exterior angle is equal to the opposite interior angle. So we're going to slap this down as our reason, exterior angle of cyclic quad. And then we've officially waxed this question, my bro. So let's have a look where the 16 billion marks come from. Your first mark comes from the statement and reason with the tan chord theorem. Exterior angles of a triangle, that reason gets you a mark. Stating that E3 is y gets you the third mark. Doing the isosceles triangle property, angles of equal sides, gets you the fourth mark. Concluding that these two are equal gets you the fifth mark, and the last mark comes from the statement and reason that wraps up this question.